The first talk is by Mr. Ramesh Renigunta from KITS Warangal, Telangana, India.
Good morning, sir. Myself, Dr. R. Ramesh, Assistant Professor of Mathematics, KITS Warangal. First of all, I would like to thank the organizing committee for giving me the opportunity to present one of my research paper entitled Triangular and Triangular Splitting Method for the Solution of Regularized Linear System. Now, the flow of my presentation is motivation, research philosophy, problem undertaken, numerical results, conclusions, and finally references. Now, motivation. Bursty behavior of internet traffic, and one of the major challenges, that is traffic engineering, performance measures, quality of services, and finally stability criteria. Now here we have research philosophy. Now we have considered a switch or router and internet traffic approaching the router, and whatever the physical problem is there, so that is modeled as a suitable queuing system, that is a mathematical modeling. Now by applying the matrix geometric techniques on this queuing system, so we have calculated the steady state probability vector, which can be used to find the study that what you call performance measures like mean packet length, packet loss probability, and overflow probability in such a way that one can dimension the router to provide quality of service to the end user. So this is the research philosophy. In most of the cases, when the network nodes are modeled as queuing systems, the problem of computation of performance measures is reduced to that of steady state probability distribution vector of transient rate matrix or transition probability matrix. Therefore, it is the key importance to investigate the pertinent linear systems. Now, in this direction, many researchers proposed the numerical methods and their convergence criteria. The stationary probability vector of a finite Markovian chain with n by n transition probability matrix P is a unique 1 by n vector pi, which satisfies pi is equal to pi p, where pi I is greater than 0 for all values of I is equal to 1 to 3 and so on n, and the sigma I is equal to 1 to n, pi I is equal to 1, where the matrix P is a doubly stochastic block circulant transition probability matrix with condition 1 by n sigma I is equal to 1 to n, pi is equal to 1. Now here the above equation can be written as pi q is equal to 0 and pi is equal to 1, where q is equal to I minus p and e is equal to 1, 1, so on. That is a vector with all entries ones, and it is a stochastic rate matrix. Now by taking the transpose on both sides of equation 3, so we have pi of x is equal to 0. So which is the homogeneous system of equations, where A and X are the transpose of the generated matrix Q and pi respectively. In particular, the coefficient matrix A has 0 column sum, positive diagonal entries, and non-positive off diagonal entries. The steady state vector pi is computed by many researchers by using different splitting methods and its convergence criteria, stochastic rate matrix Q. The significant improvements in convergence rates can be achieved from the Krylov subspace methods, two splitting and multi-splitting iterative methods. Now, here we have two alternative methods, namely Hermitian and screw Hermitian and positive definite skew symmetric methods, which converges unconditional to the unique solution of the system of equations. Now, improved convergence solution for the regularized positive definite linear system of block circular stochastic matrix using block triangular and triangular symmetric, that is TTS iteration method, is developed here. Now, here we have some basic definitions. Any matrix A belongs to R of the form A is equal to Si minus B, where S greater than 0 and B greater than or equal to 0, is called an M matrix if S greater than or equal to the row of B. If S greater than row of B, then A is a non-singular matrix, non-singular M matrix. Otherwise, capital A is a singular M matrix. Next definition, we have a non-symmetric matrix A belongs to R is M matrix if its symmetric part A plus A transpose by 2 is a matrix. Next, we have a non-symmetric matrix A belongs to R is positive definite if its symmetric part is positive definite. Now here we have one theorem. If P is block circular transition probability matrix, then Q is block circular transition rate matrix. So here we have P matrix and PJ matrix. Okay, so where P is block circular transition probability matrix of order n square by n square with block circular transition probability matrices PJI of order n by n. So from the above equation 3, so we have pi q is equal to 0, where q is equal to in minus p. Here in and p are the same order. Now here we can write the matrix q explicitly as equation 7. In the above matrix, sum of each row and each column is 0. Therefore, the matrix q is called doubly stochastic rate matrix with block circular matrices. Now here we have another theorem. If P1, P2, so on Pn are the n number of two block circular matrices, then the superposition of n two circular transition rate matrices with block circular matrices Q is equal to Q1, that is the canonical sum, plus Q2 plus so on is symmetric. So we have one corollary. Any circular matrix with block circular matrices of order n by n is non-symmetric for n greater than 2. Now here we have one result that capital P be the circular stochastic transition probability matrix of order n by n with block circular transition probability matrices, then the block circular stochastic rate matrix Q is a matrix. So we have the proof for this. So we have defined a Q transpose and Q plus Q to the symmetric part and is defined capital R. Now here we have one lemma. That is the steady state probability distribution vector is obtained by normalizing vector x. Now here we have one theorem. Let capital P be a circular transition probability matrix with block circular transition matrices, and Q is equal to, sir, Q belongs to R is a circular stochastic rate matrix with block circular matrices. Then there exists epsilon greater than 0 such that A is equal to Q transpose plus epsilon in is positive definite. Yeah, so we have proof for the result. Now the steady state probability vector pi of equation 3 is computed as follows. Using regularized linear system in equation 11 and then analyze its convergence criteria of regularized linear system by HSS, PSS and MTTS iteration solutions for general and transition rate matrices. Now here MTTS method for circular transition matrix with block circular matrices can be adopted. Let the coefficient matrix capital A of the regularized linear system, that is equation 11, can be splitted in the form A is equal to L plus D plus U. So where D is given by this matrix and L and U given by this matrix. Now, if you put capital A is equal to L plus D plus U, which is equal to T plus T dash, where T is a triangular matrix with black circular matrices and its diagonal elements are positive, and T dash is also triangular matrix with black circular matrices. So here we have triangular and triangular splitting method. So whatever matrix capital A is there, are split into two matrices, the triangular and triangular matrices. Now here we have initial guess, that is x naught. Compute the next approximation using the following scheme. So that is given by equation 13. Now the above iterative scheme could be written as this equation 14. So where m alpha and n alpha are given by equation 15 and 16. Now here m alpha is called iteration matrix of BMTTS iteration method. The solution of BMTTS iteration method converges if the row of m alpha is less than 1. So we have the proof for that convergence condition. We have the proof for that. Now here we are taking one numerical result. So for error analysis of BMTTS and Jacobi methods in the case of transition probability matrix with black circular matrices, consider the black circular transition probability matrix as P is equal to 1 by 4 times of. So we have some black matrices and the initial vector x naught is given. Now if you observe the graphs, so we have taken the graph, that is the number of iterations versus error. So the relative error of the BMTTS and Jacobi methods for the constant contraction factor alpha is equal to 0.95 and epsilon is equal to 0.2. Now in the second graph, so we have taken the number of iterations versus relative error, that is a relative error of black modified triangular and triangular splitting method for the contraction factor alpha is equal to 0.95. So here we have taken for different values of epsilon, that is 0.1, epsilon 0.2 and for epsilon 0.3. Now from the numerical results we can conclude that in this problem the steady state vector of regularized linear system of black circular matrices using MTTS method is examined, and it is proved that the coefficient matrix of regularized linear system is positively definite. And from the theoretical analysis, we can say that the iterative solution of BMTTS method converges to the unique solution of the system. And we have taken bound for the spectral radius of the iteration matrix has been derived. And finally, from the numerical results, it is clear that how well the iterative solution of the present splitting method is compared to with the existing methods. Now, these are my references. And once again, I thank you for giving me this opportunity.
Hi everyone, myself Sharanya CR, PhD Research Scholar, Department of Statistics, Bharatiyar University, Coimbatore, under the guidance of Dr. R. Vijayaraghavan, Professor and Head, Department of Statistics, Bharatiyar University, Coimbatore. My paper title is Procedure for the Construction of Reliability Sampling Plans based on Hazard Rate of Exponential Distribution. Let me start with the introduction of acceptance sampling plans. Acceptance sampling is a product control methodology to make decision about the acceptability of a lot of products based on sample observations. Reliability sampling plans comes under this category, and it consists of special rules and procedures for making decision about the acceptability of a lot of products based on sample lifetime information. Review of literature. The theory and development of reliability sampling plans based on exponential and Weibull distributions are presented by Epstein in 1960 and Gouda and Cao in 1961, 62, and 64. A detailed account of such plans was provided by Schilling and Neighbor in 2009. Gupta and Groll 1961 considered gamma distribution for modeling lifetime random variable and constructed the acceptance sampling plan for life test when the test is truncated at a pre-assigned time. Balasurya 1995 developed reliability sampling plans under the sudden death testing for the two-parameter exponential distribution. Military Handbook H108 in 1960 provides the sampling procedures and tables for life and reliability testing based on exponential distribution. Vijay Raghavan et al. In 2012 have provided the selection procedure for determining sampling inspection plans for life tests based on Weibull-Poisson mixed distribution. Life test sampling plans based on log normal distribution is constructed by Vijay Raghavan and Uma in 2016. Loganathan and Gunashekaran in 2019 developed a procedure for designing reliability single sampling plans under a hybrid censoring scheme, assuming that the lifetime is distributed according to an exponentiated exponential distribution, and compared the performance of the exponentiated exponential sampling plans with exponential sampling plans. Exponential distribution. It is one of the most significant continuous probability distribution that is widely used in statistical practice. It can be considered as a first distribution for modeling lifetime. A special case of gamma distribution as demonstrated by Pearson in 1895. Exponential distribution is having wider applications in the fields of queuing theory, reliability theory, and reliability engineering. Applications in the fields of actuarial, biological, and engineering sciences were discussed in Stephenson 1930 and Weibull 1939. Epstein and Sobel in 1953 justified the application of exponential distribution in reliability applications. Exponential distribution can be used as a model for lifetime with the components that have constant failure rate, and it is applied to the cases involving times that do not degrade with time. The exponential distribution is having the probability density function f of t theta is equal to 1 by theta e power minus t by theta, t greater than 0 and theta greater than 0, and cumulative distribution function is f of t theta is equal to 1 minus e power minus t by theta. Here, theta is the scale parameter. The mean life, median life, reliability function, hazard function, reliable life, and proportion of lot failing before time t are expressed in the given formulas. The reliability sampling inspection plan for exponential distribution. Lifetime of a product is a continuous random variable and it can be modeled using any continuous type probability distribution. Let us assume exponential distribution for the lifetime random variable, and probability of one failure before time t is obtained using the cumulative distribution function of the exponential distribution, that is p is equal to probability of t less than or equal to t is equal to f of t. The probability of acceptance of the lot under single sampling procedure is given by probability of acceptance of p is equal to summation x equal to 0 to c p of x, where this p of x can be p of x is the probability of x failures in a sample of size n, and it can be obtained using binomial or Poisson distribution, and the parameter p of the Poisson distribution or binomial distribution is obtained using the cumulative distribution function of the exponential distribution. The designing criteria for the life test sampling plan. The criteria for obtaining the optimum parameters of the sampling plan are obtained as the two-point approach. That is, the OC curve should pass through 2 points, P0 1 minus alpha and P1 beta. And the criteria can be written as probability of acceptance at P0 greater than or equal to 1 minus alpha and probability of acceptance at P1 less than or equal to beta. P0 is the acceptable proportion of the lot failing before time t, and P1 is the unacceptable proportion of lot failing before time t. Alpha and beta are the producer's risk and consumer's risk respectively. The designing of life test sampling plan. here P0 and P1 are the proportion of lot failing before time t, and it is related to the values Z0 and Z1, where Z0 is the acceptable hazard rate and Z1 is the unacceptable hazard rate. Now, the criteria for obtaining the optimum plan can be rewritten as probability of acceptance at Z0 greater than or equal to 1 minus alpha and probability of acceptance at Z1 less than or equal to beta. Or it can be rewritten as probability of acceptance at TZ0 greater than or equal to 1 minus alpha and probability of acceptance at TZ1 less than or equal to beta. Why is that? Because the proportion of lot failing before time t, that is P, is a function of TZ0 rather than Z. Numerical illustration. Consider the case of a manufacturer who is purchasing certain equipment in larger quantities. The experiment shows that the lifetime of the product follows exponential distribution. A test period of 1200 hours has been agreed upon. Experience with the product has further indicated that a competent supplier should be able to submit lots for which the hazard rate at 1200 hours is 0.003. That is T set not of T is equal to 0.003. Furthermore, the user has ascertained that if the hazard rate for a lot is 0.008 or more, use of the component will lead to much difficulty. That is T Z1 of T is equal to 0.008. From the given requirements, the sampling plan can be obtained which satisfies the two conditions with specified producer's risk and consumer's risk at 5% and 10% respectively, as N is equal to 1781 and C is equal to 9. So the sampling procedure for the single sampling plan is as follows. Draw a random sample of 1781 items from the lot and place them for live test. Stop the experiment at time t equal to 1200 hours. Observe the number of failures m before time t and accept the lot if m is less than or equal to 9 and reject the lot otherwise, where c equal to 9 is the acceptance number. Conclusion. Optimum parameters of the live test sampling plan is obtained under the assumptions of exponential distribution indexed by hazard rate. Operating characteristic values for different proportion defective values obtained. The values of T by mu into 100, T by mu D into 100, Tz of T into 100, and T by rho into 100 are obtained for different values of proportion defectives, which can be used to obtain the sampling plan when the acceptance criteria are mean life, median life, hazard rate, and reliable life, respectively. These are the references followed. Thank you.
Thank you all for participating in HALABS 2020. Once again, we welcome you all for IWMS 2021, which is going to happen in December 13 to 15, 2021, and ICLA 2021, which is going to happen in December 15 to 17, 2021. Thank you all once again. We'll see you in the next conference. Thank you.